Bismillahirrahmanirrahim. This short video is from end chapter problem 88.17 from Mr. Irwin's book. And here I'll be solving this problem on the request of a student. And there's a very interesting concept, so you must see till end. Question is, find the value of the capacitance. So we need to find this capacitance shown in this circuit so that IT, the current IT, will be in phase with the source voltage. So this is the source voltage. We want this current to be in phase with the voltage. Now, first of all, we have to convert the circuit into frequency domain or phasor domain. Omega is 250. From here you can see cos omega t. And we know how to convert resistance, inductance, capacitance into phasor domain. Especially for capacitance, I prefer to use this minus J divided by omega C instead of 1 over J omega C. And we have converted this circuit now. V60, magnitude 60 and angle 30. Resistance no change. Capacitor minus J over omega C. And this is J omega L. So J omega is 250 multiplied by 40 millihenry will give it J10. Okay, so this is the circuit that we converted into phasor. And let's read the question again. Find the value of the capacitance C so that IT will be in phase with the source. So this current IT has to be in phase with the source. Now keep in mind that the current is in phase with the source only when the load is resistive. That means this has to be resistive, only then the total circuit will become resistive and the current will be in phase with the voltage. So Z should present an overall resistive load. That means its phase angle should be 0. So when it becomes a resistive load, its phase angle will be 0, and so the phase angle of the voltage will be the phase angle of the current. Now let's write this Z. You can see 15J10 in parallel with the circuit. So solving. I hope you know how to write this equation for two parallel arms. Simplifying and collecting the terms, the real and then imaginary. Also a point just to note for those who don't know, the J multiplied by J is actually equal to -1. So J multiplied by this J will make minus, and then with this minus sign it will become plus. Okay, now the interesting point. The angle of Z will be angle of this one divided by angle of the denominator. So angle of the numerator, we're calling it theta n, and divided by angle of the denominator. And we can write it in this form as well, because we know that the angle at the denominator goes at the top with the negative sign. So that means theta n minus theta denominator. And now the requirement is that this angle has to be 0, as we have talked here. So if this angle has to be 0, that means theta n should be equal to theta d. And if we take tangent on both sides, so tangent theta n should be equal to tangent theta d. Now, why we are taking tangent? Let's see from here. We know that if we have a z in terms of r and x, we write it like this, and from here we write the theta to be tangent inverse x over r. And if we take this on the left hand side, then we can also write it tangent theta is equal to x over r. So we'll be using this property actually. That is why we have taken tangent. So tangent theta n, that is of the numerator, according to this will be x, that is the imaginary term divided by the real term. Now this is the imaginary term divided by the real term. So we'll write it like this, minus 15 omega c divided by the real term. And similarly, tangent theta d will also be imaginary term divided by real term. Imaginary divided by real term. And now we'll simplify this. So omega c gets cancelled from here. So this is a slightly simplified form. We'll simplify it further. So from here, if you just cross multiply, we get this value. Further simplification in this term. And now from here we can calculate C. First of all, omega C will be 10 divided by 325, and C will be 10 divided by 325 divided by omega, and we know the value of omega is 250. So solving this, we get C to be 123.077 microfarad. So I hope you have been able to follow this and you have learned the concept. Thank you.